My dear students, my dear friends, today we'll discuss few more concepts related to stack. In the previous class, we discussed about the stack. That is, what is stack? What are the operations which are there in the stack? So many concepts were discussed in the previous class. Today we'll discuss few more concepts related to stack, and also we analyze the stack using the array. Using the array, we have how we can array representation of the stack. In the previous class we discussed about that with a program. Today we'll discuss a few more concepts related to stack. That is, how we can represent the stack using the concept of linked list. That is, how we can represent that one using linked list. Therefore, with a program, we'll analyze about the stack using the concept of linked list. That is, program for creating the stack using the linked list. In that, program performs all the operations such as push, pop, and display. It takes care of a stack underflow condition. There cannot be stack full condition in stack using linked list. That is, since we are representing the stack using the concept of linked list, there is no full condition of the stack, because here we will use the linked list uses the dynamic memory allocation. Therefore, there is no question of stack full condition. Therefore, how many memory location we require, that much memory location we can allocate for the stack. And the program is that hash include istream.h, hash include stdlib.h. These are the instructions, or these are the header files. Already we know that why we use header files. Then we will have the class links. This is the name of the class linked stack. Name of the class is nothing but L stack. That is class L stack. This is the name of the class. Then we know that the class is having the private members, the public members. Therefore, the private members are that is type def struct stack. Here int data struct stack. Next, here, since the linked list is having two fields, that is data field and next field. Therefore, we will represent this one using the concept of structure in the stack to represent the node of the stack. That is, here int data struct stack. Next, this is node. Then node is nothing but top of the stack. Then public. These are the public functions of the class L stack. Then what are the public functions? This is the L stack is, this is the constructor, this is the destructor, and other functions are void create, remove, show, void push, void display, int pop, int stack empty, and these are the member functions. These are public functions. This is private members of the class. Private members, public members of the class. That is floor bracket, semicolon, then it means end of the class. That is, here this end of the class we have defined, we declare the data members, the functions of the class. Then we'll define those functions. Here use the constructor, we use the destructor, we use the create function, we use the remove function, we use the show function. So many functions are there. We'll define those functions one by one. That is constructor. Constructor is there to initialize, to allocate the memory location. We use the constructor. Here, using this, we can allocate memory to the to store the data into the stack. Similarly, we use the destructor. This is nothing but, this is the destructor. This is the destructor, and this is we have defined what is destructor, how it will operate. We have defined here. These are the instructions used for to destroy the memory allocated for the stack. Then is the one more is that is create function. This is the using this function we can create the stack, that is we can create the stack. Means what is the first node, what is the second node, what is the third node. These we to create the stack, using this create function we will create the datas, the memory the next fields, everything will store, will have, will find out, will come to know, will create using this create function. Here void lstack scope resolution operator create, then int data, then in data, then enter the data, enter using cout enter the data, cin means we will enter the data. Then here we will use the push function. This is push function. This using this push function, next push function, using this push function we can insert the data into the stack. We can insert the data into the stack. Therefore when we insert the data, go on inserting, then in push function we have defined, we have mentioned how we can insert the data, what happens, so everything we have mentioned in the push function. That is using this function create function will we will create the stack. We'll create the stack, how we can store the data, how we can create means what we can, how we can create the list, or how we can create the stack means how what are the numbers which will be there in the stack, everything creation of that one. Remove the function. One more is that remove function. One more function, when we are created, when we have inserted the data into the stack, then afterwards suppose we want to remove that one, at that time using remove function will remove that data. In the, that is in this function we are having void link stack scope resolution operator remove. In this we are having int item. If stack is empty, if no data is there in the stack, then how we can remove? If something is there we can, if data is not there, how we can remove the data? Therefore using this stack empty function will come to know whether stack is there or not. If it is there, if it is not there, then stack, it has to display stack is empty or stack underflow. Else using item, using item equal to pop and top equal to this, we can pop means retrieving the data from the stack is nothing but taking data, accessing that data is nothing but the pop function. Therefore remove means or taking, remove or accessing, deleting, all are same. That is using pop function we can remove or delete or retrieve the data from the stack. Push for when we create, at the time we have to insert the data. Therefore we use the push function in create push instruction in the create function. Like here we have defined so many functions: create function, remove function, then show function. In show function use that is to show means what are the elements in the stack. For example, we have inserted 5 elements 10 20 30 40 50. At that time 5 elements are inserted. To display that one, using the show function we can display the contents of the stack. Therefore at that time we can, when this function is executed, at that time it will display the content of the stack. Similarly the push function. In push function, this is, we know that why we use push function, to insert the data into the stack we use the push function. At that time here how we can insert the data, that is void l stack push int item int node top, node equal to new equal to new node. Here we can, using new will allocate a memory for the store the data. At that time when we allocated new next equal to, we know that the node is having two fields. That is node is having a node is having two fields. That is, this is the data field, this is the next field, this is node. in the linked list, suppose this is the data. This will have, first it will have the null. After this is have the null. This is the data, and this is here we have created the, this is the node which contains the data, and this contains the next field to which node it has to represent, to which next data, which data we want to store. For example, we want to store here 10, 20, 30, like at that time, suppose 40, like this we store the data. At that time, this field tells to which memory location it has to, this field tells to which memory location it has, this field tells, like this. Here this field tells the address of the next memory location, next which data we want to insert, next location which in which we can insert the data. Therefore, here using this push function, and also using concept of no next equal to null, first this will be null, this will be null. After that, and that this is the data, new data item means this is the 10 data. Next new equal to next top means now it, after inserting this, it will point to this next because after inserting the top of the stack should point to this location. Why? Because after this it has to insert to this, we know that is top of the stack, top will point to where we want to store the data. We know already we discussed in the class the top of what is top of the stack, what is push operation, what is pop operation, what is stack empty operation, what is stack full operation, everything we discussed. Here new next top equal to new, so that it will point to next memory location where we can insert few more data into the stack. That is about the push function. Next, then we have the stack empty function. In empty function we are having a L stack empty node. If tab equal to null, return 1, else return 0. That is, if it is stack is empty, return to 1 or else return to 0. Similarly, this is one more function we have defined, that is pop function. When you use the pop function, at that time these are the instructions which are there in the pop function. That is, here int item node temp, temp item equal to top, item equal to top, that is data, temp equal to top, top equal to, here using this top equal to top next delete temp. Using like this, these instructions, we can delete the data which is there in the node. Then the top should point to the next location where the data is there, because after deleting that top of the stack is point to then the other location which is there in, for example, here in the stack we are having the 10 data, 10, 20, 30, 40, 50. At that time, suppose these are the data. Suppose we want to remove this 30. When we remove this 30, at that time data are there here. When we remove 30, then 10 is having the address of 20. 20 is having the address of 30. 30 is having the address of 40. 40 is having the address of 50. Suppose I remove this, then this 20 should point to not to 30, it has to point to 40. The top of the stack or the this address of this should not point to this address, this memory location, it has to point to this memory location. This is after deleting this 10, 20, this address. You know that the node contains the data field, the next field or link field. This will tell we have to store the 20 in this location. This will tell that the 30 has to store in this location. This will tell it has stored like this. When we remove this, at that time this address or link should not point to this, instead it has to point to this. For that, using this instruction, that is item equal to top, data temp equal to top equal to top point to the next location, delete temp. Using like this instruction, we can delete the item or data, and also the next field will point to the next data, which is to be pointed by the top of the stack. This is pop operation. Similarly, we are having the display function. We are having display function, that is int l stack display node head, node equal to temp equal to head. If stack is empty, it has to display the stack is empty. Otherwise, while temp is not equal to null, then cout temp data, it has to display the data, and temp equal to temp. Next means after first using this instruction, we can display one. After using this instruction, we can point to the next data. And since here while loop is there, where is the while? While is here, therefore it will display all the elements which are there in the stack. That is, suppose 5 elements are there, 10, 20, 30, 40, 50. First it will display this. After this temp will point to next data. Using this while loop, it will display all the data which are there in the stack. This is the display function. Then here so far we have defined all the functions. There is a display function, pop function, push function, then so many functions we have discussed in the we have defined so many. Create function, and then show function, push function, so stack empty function, pop function. We define all these functions. Afterwards, what happens? The main starts. Int main, int choice, clear, char, answer, ch. These are the we have to mention. If suppose we take the variable choice, what type of variable it is? Either it is int, float, everything we have to mention that one. Therefore, we have defined we have mentioned about the data type of these variables. That is, what is about choice, what type of answer is, what is ch, what type it is. We have we have declared those data types, the variables data types. Then l stack st. Here l stack st important. For l stack we have created the object est. Important when we using class. This is what l stack is, what the name of the class. Important, very important. Here this is the name of the class l stack. Therefore, when we use that function, we have to create the object for that class l stack st. Then using this object, we can call the different functions. Whatever function we want to call, using this object, we'll call those functions. For example, next, then it is the main program. Int main program starts here. Then int main, then cout stack using linked list. Stack here, this is the program stack using linked list. Then here do while, here we use do while loop. Then in that loop we will mention cout the main menu. When use this, when we execute the program, at that time it will display the main menu. In that we'll next we'll display. First operation is push, second is pop, third one is display, fourth one is exit. Next, it will display the enter your choice. Out of these four, one is push, second is pop, third one is display, fourth one is exit. Out of this, it will display enter your choice. Suppose see enter your choice. Depending on those choice, it will execute those function. That is, using switch operator. Using switch operator, we can have the choice. Suppose depending on the choice, suppose you press 1, it will push the data into the stack. Suppose you press 2, it will pop the data from the stack. Suppose you press 3, if you press or you the choice, your choice is 3, at that time it will display the content of the stack. If you select the choice as 4, then it comes out of the program. That is, using switch we can you select any function. That is case 1. It is what? st create. Using this function will create the stack. Create, when we use the create, at that time what happens, when this is executed, at that time it will come to the create function. Where is the create function? Here is the create function. Then using the enter the data, and it will ask enter the data. Then you have to enter. Using the push function, it will insert the data. In push, we have mentioned when it push function is executed, how it will insert the data, how it will take the data, everything we have mentioned here. At that time, suppose you see here, for example, we entered 1. Suppose here the main menu, here in the program we have mentioned about the main menu. Then one is push, the second one is pop, third one is display, fourth one is exit. Enter your choice. Here you written enter your choice. Suppose enter your choice. Suppose you enter one is what? Push. When one is push, then it will here case 1 create the function. In create, it will go to create function, it will take the data, and using push function it will insert the data into stack. Then break means when break executes, then it comes out the switch loop and it will execute what? Do you want to continue? No, you do want to continue? And then yes, do you want to continue? Here you say, do you want to continue? If suppose yes, if you type yes here, answer is yes. At that time, while answer is yes is equal to yes, then once again it will repeat the loop. And it will come to here switch statement. Once again, the main menu, push 1, push pop or 2, display, exit, like that. Enter your choice. Suppose once again choice, enter your choice. Suppose you enter 2. At that time, here case 2 is what? st remove. When this suppose you enter 2, at that time it will case 2 is executed. Case 2 what? Remove the data which is there in the stack. When this function is executed, it will go to that function. Where is the remove function? This is remove function. In remove, what happens? If it will first, it will check the stack is empty or not. If it is empty, it will display stack is under flow. If it is not empty, then it will display the pop function. Item pop means the delete the function, remove the function, or delete the data, remove the data, or retrieve the data from the stack. And then it will pop function. Here you see here pop will how we can delete. Already we have defined that one. After delete pop retrieving the data, it will display the pop node is item, like depending on these functions. Suppose then once again after this it will break means it comes out of the loop. Then it will ask, do you want to continue? Suppose yes, then s is equal to yes, the condition is satisfied. Then once again the loop repeats, and suppose you select your the interview choice. Suppose your choice is 3. At that time, what is choice 3? Show means at that time it will go to the show function. In show function, what is there? In show function, display the content. Using the display function, it will display all the elements which are there in the stack. Like this, it will display all the contents of the stack. Like this, it will insert the data, it will remove the data from the stack, or it will display the data. Fourth one is exit from the program. Exit. Suppose when suppose you enter here, suppose you enter 2-3 datas. After that you don't want to enter, or you don't want to do some operation. At that time, do you want to continue? Suppose you write as n or no something you write. Suppose you write n. At that time, what happens? While n is equal to y, n is equal to y. No, n is not equal to y. Y is equal to y. N is not equal to y. Therefore, condition is failed. At that time, it will not go to this loop, do while loop. it will not go to do while loop here. Instead of that, it will come out of this loop and return 0, stop program, stop executing the program. Here the program ends. This is how the program executes. This is how we can represent the stack using the concept of linked list. This is the program. This is how we can create we can create the list, how we can creating the stack and inserting the data into the stack, retrieving the data from the stack, displaying the content of the stack. So many operations we can perform using the concept of linked list. This is one program. Because why I'm making this video, because in the class we have analyzed the stack using the array representation, but here we will analyze the concept of stack using the concept of linked list. Like this, so many concepts are there in stack. These are the concepts which are related to stack. Here this third module is over. These are the important concepts whatever there in the stack we have discussed. If still you want further so many concepts related to stack, you refer the book. They have given so many concepts related to stack. This the third module is over. In next class we'll discuss the fourth module related to data structure using C++. Okay, thank you.